Welcome back. In the previous video, we discussed options to reduce energy consumption for heating and cooling. In this video, we will discuss the supply side and will present available options to reduce CO2 emissions when producing heating or cooling to keep a building comfortably warm or cool. Let's start with the most common way to produce heating within buildings, which is locally supplying fuels to a building and convert these fuels inside the building into hot water that is being used for space heating and hot tap water. When fossil fuels are supplied, this leads to CO2 emissions at the building site. Some commonly used fossil fuels include natural gas, coal, and oil. Inside the building, these fuels are supplied to a boiler or stove to produce the hot water. CO2 emissions per gigajoule of heat used in the buildings will depend upon two factors. One, the type of fossil fuel being supplied. As you can see, CO2 emission factors for the various fuels differ, with lowest emissions for natural gas and highest for coal. Secondly, the conversion efficiency of the installation used within the building. Highest efficiencies are achieved in the conversion of natural gas in a high-efficiency boiler, typically around 90%, and much lower efficiencies when using coal or oil in a traditional stove, with efficiencies between 30 and 40%. Thus, we can conclude that one way to reduce CO2 emissions for heating is by shifting from high-carbon fuels, like coal, to low-carbon fuels, such as natural gas, and from low-efficiency technologies, like traditional stoves, to high-efficiency techniques. CO2 emissions can be further reduced by using biomass. Biomass energy is considered carbon neutral if growing biomass removes as much CO2 as is emitted into the atmosphere from its combustion. Keep in mind that biomass can have a negative impact on local air quality, so it needs to be carefully considered. A second way to produce heating in buildings is by means of electricity. This usually implies that the building is connected to the electricity grid. Inside the building, the electricity is converted into heat. This electricity is usually produced outside the building. For this production of electricity, either fossil fuels, like coal or natural gas, and/or renewable sources, such as wind energy, are used. When fossil fuels are used, this leads to CO2 emissions. As you might remember, we labeled these as Scope 2 emissions. Now let's investigate some options to convert this electricity into heat inside the building. The first option is using a simple resistance heater in which electricity is converted into heat for heating a room. A more advanced option is the use of a heat pump. A heat pump uses electricity and energy from the outside air or groundwater to produce heat for space heating and hot water production. The advantage of using a heat pump is that besides producing heat in cold period, it provides cooling in the summer period. The efficiency of a heat pump is expressed in COP, coefficient of performance, which is calculated by dividing the delivered amount of heating and/or cooling by the electricity supplied to the heat pump. The higher the COP, the more efficient a heat pump is and the less energy it consumes. Typically, 1 unit of electricity delivers 3 to 5 units of heating. Please note that the heat produced by a heat pump has a lower temperature than heat produced by, for example, a gas boiler. So to have a comfortably warm building, it needs to be sufficiently insulated. The third option is supply centrally produced heat by connecting a building to a heating grid. This can either be a large citywide heating grid or a small local grid. In both cases, the heat is produced centrally and subsequently transported and distributed to the buildings connected to this grid. Inside the building, the delivered heat is being used for space heating and/or hot water production. As you can see, the heat is produced outside the building with either fossil fuels or renewable sources. In case fossil fuels are used, this leads to CO2 emissions which are emitted outside the building. So these are also Scope 2 emissions. There are several heat sources being used to supply heat to buildings, like waste heat from industrial processes or heat from CO2-free sources like a geothermal well. Please note that heating grids are only applied in densely populated areas because investments in the transport infrastructure are high, and in order to be able to recover these costs, you need a very concentrated high heat demand. Finally, we can use energy from the sun to supply heating to a building. In this case, energy from the sun is used directly to produce hot water for space heating. Now, let's summarize these different options for our fictional city by analyzing how the different options affect CO2 emissions. In this table, we have calculated CO2 emissions per gigajoule of heat delivered to the end user for the different options and ranked them from low to high emissions. You could easily conclude that we simply need to move up the ladder to limit the CO2 impact of heating. However, as discussed earlier, there are some issues and restrictions that need to be considered. CO2 reductions need to be balanced against the impacts on local air pollution and upstream CO2 emissions. District heating can only be applied if heat sources are in the proximity of relatively densely populated areas with a concentrated high heating demand. CO2 impact of options that require input from electricity strongly depends on the efficiency and CO2 contents of the sources used to produce this electricity. So far, we discussed heating, but also noticed earlier the demand for cooling is increasing. Due to rising temperatures and increases in income, this means that more and more people can afford to buy air conditioning equipment. Like with heating, the most effective measure to reduce CO2 emissions is to prevent the need for cooling. For example, by applying insulation and designing buildings in such a way there is no need for cooling or the need is minimized. This picture shows some air conditioning equipment which is currently widely applied inside buildings. These cooling devices all require electricity, and as we have seen with heating, this electricity first needs to be produced elsewhere, leading to CO2 emissions in case fossil fuels are being used. An important first step to bring down the CO2 impact of cooling equipment is by increasing its efficiency. This graph shows the typical efficiency of cooling equipment for some world regions. The red dots represent the average efficiency of cooling equipment sold on the market in a specific region. The blue dots represent the best available on the market. It's very clear there is a substantial room for efficiency for cooling. Thank you for watching this video.